Thank you, thank you. So, the title is intentionally vague, but hopefully a lot of fun, and I plan to deliver on all three of these things. So today I'm going to be talking a little bit about a research project that I've had going for about the last year. Well, first, why don't I talk a little bit about myself, because that's, I think how you're supposed to start a talk. So anyway, I'm Paul Melson. I work in cyber threat intel and custom detection at Target. This is my fourth time at BSidesAugusta, and thank you to the volunteers that put the event on and all of you that come out. This is one of my favorite conferences, and so thanks for that. So you can follow me on Twitter at pmelson. You can follow my project that I'm going to be talking about today, Scumbots, on Twitter at Scumbots. And if you want a copy of the code that I use to do most of this work, you can pull it out of my GitHub repo. So a little bit about the premise that the research is based on. Backing up a little bit, everybody kind of has an understanding of what magic file numbers are, right? That the first few bytes of a file will tell you kind of about the file and what it does, and in particular that Windows binaries or PE format files. I'll start with MZ, or in hex it's 4D5A, so that's a useful thing for being able to identify that a file is in fact a Windows binary. And this started as a little bit of homework during my day job. Just hey, what does it look like when a PE file gets encoded and shoved into like a Word document? And what are some of those encoding schemes? And so I've been playing with and tracking malware families and binaries for a while, and so I decided I have this malware zoo. If you've been to any of my previous talks, you've heard me talk about that. And so what I did was I just ran some basic byte extractions over that entire zoo, and what I discovered was there's really only it turns out like 9 unique byte preambles. There are ways to make more, but really in the wild, there's only about 9 unique byte preambles that uniquely identify a PE header. Because 4D5A as a byte sequence happens like all the time in the wild for lots of reasons, right? If you were to just say, hey, this file has the bytes 4D5A in it, that wouldn't be particularly interesting to you. But if we could expand that out a little bit more, maybe we could detect the presence of PE files. And that's really the genesis for this work. So I started playing around with some encodings. And so this is base64 on the left. That's decimal encoding, which if you've ever played with byte strings in .NET, .NET will do this to you. .NET also has this horrible mode where it will intermingle decimal and hexadecimal because it hates you. And so I was playing with some of this work, and what put me on the path to this research project was, well, Twitter, right? And so I'd been playing with some of this. I tweeted out some of the stuff I just showed you about base64 encoded PE headers. And Xavier Martens, who's one of the SANS ISC handlers, did a little blog post about it. And which is cool, like that's fun. At the end of it, though, he mentioned, and I'm adding these to my pastebot scraper. And I went, you're what now? So, and I did a little homework, and it turns out that Pastebin, everybody familiar with pastebin.com? Right, so Pastebin's a free, anonymous, like, copy paste, and there are a number of others out there, and those could be interesting future research projects, I suppose. So it turns out that they sell access to their scraping API. Like, they actually will let you give them some money, and you can get all the pastes off Pastebin, like as they happen in real time. And basically what they do is they let you whitelist one IP, and you can beat that API up to a particular rate limit. I think it's 1 per second, which is usually plenty. So from Xavier's ISC post, I got this idea, and I built this project that I call Narc, or Scumbots, because that's what I called the Twitter bot, because Narc was already taken. And this is the architecture. It basically consists of sort of three components. There's a scraper, there's a parser and processor for the scraped data, and then there's a post-processor that does some interesting, it does some enrichment, some analysis, and then it blabs to the world about this thing I found. And the reason that I called the title Tracking Script Kiddies and APTs with Beer Money is because all in that Pastebin lifetime. So by the way, like if you're interested in doing this research, keep an eye out. They put it on sale. I got mine for like 20 bucks, lifetime, unlimited, single IPA. Like it's like probably the best deal going in like, raw data for Intel sourcing. So Pastebin Pro license 1995, and then one T2 micro at about $936 a month to run the scrapers. All in, a year of this cost me $132.27. As I was saying to somebody in the audience before I started talking, that's a whole lot less than I spend on beer in a year. So, so a little bit about the architecture. So Paste Eater is the actual scraper. This was kind of fun to have to play with this. I originally started with a design where I was going to do it all in Yara because Yara's awesome, and discovered that in order to get like really, really fast, reliable like hunting times, right? So the initial scraper I decided could accept a high degree of false positives as long as it was catching stuff that was probably interesting and shoving it into a queue, and then we could determine later asynchronously if it was really interesting. And so instead what you'll find is it's just a bunch of raw Python string matching that's just optimized for speed. I don't use Yara or anything like that, but it's pretty human readable code if you check it out. So it evaluates the pastes. I did a little bit of tuning based on size and type, because Pastebin will try and parse those the pastes for you and tell you what language they're in, and if it doesn't know, that's usually pretty interesting. And sometimes even when it does know, also interesting. Also, if it's megs and megs, it's probably not malware. And also if it's like 12 bytes, it's definitely not going to be malware, right? So download some interesting raw pastes, fast text search, and anything that's useful or might be interesting, we save it. Base jumper, because the first thing I started messing with was base64 encoding, and I'm bad at naming stuff. So base jumper just validates for the detected encoding type. So it looks like base64. Is it really base64? Strips out white space and delimiters, kind of cleans it up, decodes it to a PE file, and if it's all successful, right, it cleans up all the raw leftovers. I co-opted a project that was written by Brian Wall called BAMF Detect. A lot of the code contributed to this was also put together by Kevin Breen. So BAMF Detect is an open source Python framework for doing malware analysis. And really its primary function is stripping configs statically from known malware families, right? So if I know this is this particular family of malware, I know where to go and what to do with the bytes to tell you who it's going to call out to, what its configuration settings are. It's a decoder. So I just forked this for my own purposes because that way I didn't have to write the whole thing from scratch, and I could just add functionality as I went because it was had a modular design. So BAMF Detect will identify whether or not the PE file that I found is malicious. If it knows what it is, we rip that out and hand that off in JSON format, which was another thing that made BAMF Detect really nice, is all the output was in JSON, so real easy to handle. And then that passes it off to Narc. So Narc actually is what calls BAMF Detect, pulls C2 out in JSON. It moves any files that we don't identify, though, go in a research folder, which is fortunate for all of you because that's going to actually be more of what I talk about in a little bit. So we check the C2 against the IP info, as I showed you in the diagram, log some information about that C2, like geolocation, the ASN numbers, things like that. Upload the sample to virus total, and then comment on the virus total upload. So if you ever see the stuff that comes off the bot and go search that hash on virus total, you'll see that the bot has also gone out and commented, left the C2, positive ID on malware because we got the C2 out. And then we tweet it out because, why not? And then clean that up. So that's basically the framework. That's how it works. This is Scumbot, and if you go check him out, he's constantly dropping docs on, what was it? I drop docs on scumbag bots and rats. So mostly it's just an ongoing feed of malware I found on Pastebin. So cool, right? Like I built a thing that will find malware and tell us about it when it happens on Pastebin. The time cycle is start to finish, usually just a few minutes from when the paste gets uploaded to the time that it hits Twitter and VirusTotal, which is kind of cool. Not the best if you're a bad guy, but that's kind of the point. So, but that's cool that I wrote a bot that will tweet this stuff out. But what could we do with that data in aggregate? And how often does, you must be asking yourself, how often does this happen, Paul? Well, the answer is all the time. So to date, I've collected about 14,000 known samples and 20 out of, so I've identified 20,000 suspicious pastes, about 14,000 known malware samples out of that that the bot has processed on its own. So we have a pretty good data set from which we can actually do some additional analysis, right? So here's a pie chart that kind of shows you the encodings that I'm detecting. Some of these are skewed a little bit just by timing because I started with a handful with hex and base 64, decimal, and binary, and have kept iterating, adding things like compression and other forms of obfuscation as I find them and learn about them. So some of these haven't been in the data set for a full year. You can see bad guys like to do things like add, well, hey, if base 64 encryption is good, double base 64 encryption must be better. So we had somebody try that at least a handful of times. Hex encoding base 64 encoding hex. It's all, it's just how many different times can you iterate through it, trying to beat the detection. And the answer is, as long as we know to look for the obfuscation in the first place, then we can kind of touch it and handle it and see if, see what falls out the other side. So some malware stats. The vast majority of what I find on Pastebin is NJRAT. Also sometimes called Bladabindi by some of the AV firms, but still seeing a significant amount of Nanocore, Revenge. There's a good amount of Meterpreter Venom loader out there. But there's just a whole mess of other things that are out there. Agent Tesla has started to creep up. I've caught some Cobalt Beacon. So that's not as skiddy land as maybe NJRAT is, so maybe we'll talk about that a little later. Where are we seeing C2? Netherlands is number one. The reason for that is not because the Dutch are necessarily notoriously evil, it's because Lost Oasis has all their ASNs based in the Netherlands, and Lost Oasis is a hive of scum and villainy. If you're not a researcher and you just have to defend a network, I would just go pull the Lost Oasis ASNs now and block them at your edge router, right? Like there's nothing good's going there and nothing good's coming from there. Sorry, Lost Oasis, but it's true. And about 50% of the Swedish stuff is Relax VPN. So there's, these aren't necessarily indictments of these countries and certainly not good for attribution. What they're really good for is telling you where a couple of the shadier ISPs in the world are. So to that end, here's the ASN. So you can see Telecom Algeria, Lost Oasis is of course a big one. So some interesting stuff. Saudi Telecom, Port Lane, DigitalOcean. You're all shocked. They made the list. And then another thing that's a really, really common piece of Kit is they'll use domains or FQDNs for C2. So yeah, they'll host at Lost Oasis, but they'll use free tier dynamic DNS for some of this. So these are second level domains that by frequency. DDNS is definitely the number one, but we see quite a few. And this list, so this is like the top 10 or whatever, but this list is pretty long. And basically, if there's a dynamic DNS domain out there, I've seen malware use it for C2. So that's another thing that I think you should do if you don't know that you have a business case for dynamic DNS in your environment. Go get a list of the names, kill them all at the edge, or at the very least, go hunt them in your proxy logs because there's probably interesting stuff in there. Okay, so that's cool. I ran some stats. That's neat. But what's interesting about that is if we overlay those, because there's a couple of clear winners across the top, we're going to actually use those stats to put together what I would say is an aggregate set of TTPs, right? So we could describe a typical actor without really knowing anything about any of the actors specifically, just by observing this behavior at a particular slice in the kill chain, right? So if you pause and think about this as we're observing an attack in its staged state, right? So stage 2 malware is set up on Pastebin for somebody to come get after something happens in their environment. And then there are later actives and objections once command and control is established and the bad guys got access to the environment. So we're looking at a very specific slice of the kill chain as we're scraping here. But it's interesting because we can still build out some specific list of tactics that we know that they use on average, right? So they stage on Pastebin, that's kind of the point of the exercise. But base64 encoding, NJRAT, free-tiered dynamic DNS hosting with no IP, and they probably host at Lost Oasis, right? And so what we have here is a set of TTPs that describe, as far as I can tell, probably a couple hundred individuals. And really, if you take this set of TTPs, start doing a little bit of homework and start looking around, what you'll discover is there's a handful of, we'll call them hacker boards on, is it deep or is it dark web? If it just has a password and Google can still scrape it, that's just the deep web, right? I forget, anyway. So on some hacker bulletin boards where you and I can go, you will find people basically passing around how-to kits and software on how to do this. So this is data, and what I do for my day job is I do threat intelligence, so we have to turn that data into intelligence, right? Because I'm not done with graphs. So one of the things that's interesting is that I track the users that upload the pastes. A lot of these are anonymous, which isn't helpful, but when they're not anonymous, that's like super helpful. Because even if this doesn't uniquely identify the individual, it tells me somebody with the control over this account, this person, did these actions. And so by overlaying the paste key with the FQDN extracted from the C2, tied to the IP, tied to the family of malware, tied to the user, just created a basic table in a spreadsheet, and then did what all good threat intel analysts do and imported it into Maltego. And I'm just going to yada yada over this, but basically what I discovered, right, is that there's an overlap at both the user and the infrastructure layer for every family of malware that I've been able to track, right? Like that for all of these commodity rats like Revenge and Nanocore and NJRAT and Extreme, there's somebody playing around with both. There's overlap across all of them. So that's potentially interesting because if nothing else, what it tells you is that there's some level of connectivity in the community and availability of these tools. So what else can we do? Because like I said, I'm not done with graphs. Pew pew maps, right? So another thing I did is I wrote some basic Python to take the extracted C2 information that I'm recording and turn it into KML files, which you can then upload to the Google Maps API, and it'll generate a cool little map like this. This one's not especially useful, but it's just kind of neat to show off that I could do it based on the GeoIP mapping. So there's Nanocore, there's Dark Comet, which is interesting, right? Because all of a sudden, as you get into the rarer stuff, now we're probably talking about a much smaller subset of actors, and we're starting to see some geographic concentration, right? So one of my Dark Comet actors is got some tie to Brazil, whether that's where they're targeting or where they're operating, hard to say for sure, but definitely there's some connection there. Similarly throughout Europe and a little bit of Africa, but I would say that those geo concentrations suggest there's maybe a half dozen actors, and at least one or two of them really care about Brazil. And then this is Cybergate, same thing, concentrations in Europe and Brazil, and I'm guessing if we go back here, we can probably find those lines in that Maltego graph as well. All right, so that's the end of the commodity malware stuff. Let's talk a little bit about some of the more interesting stuff that the bot hasn't pushed out to Twitter. So anybody familiar with Aegis Cryptor or Aegis Cryptor, however you say it? Anybody know what this is? So Aegis Cryptor is a site that sells obfuscation services for Windows executables. You take a Windows binary, you give this dude some money. I believe that he takes Bitcoin and e-gold, like all good legitimate software vendors. And you can submit a file for crypting, and he will then return to you your same program, but now obfuscated so any virus can't find it. And I stumbled on Aegis Cryptor because it turns out that when they're serving, they post the error page to Pastebin, ostensibly for support purposes, right? The post failed, so a copy of the post goes to Pastebin. Do you see what I see in the post body? You get a copy of the would-be bad guy's malware before it's been packed, hex encoded, posted to Pastebin. And this has happened several hundred times over the year that I've been observing it. So Aegis Cryptor is actually just leaking unobfuscated malware right back out to Pastebin for us, almost like they wanted to help. So let's see. MSF Venom, so Metasploit Venom. Venom's just a loader. It's a lightweight loader for portion of Metasploit framework, and does it's basically obfuscated shellcode loading. It's kind of a pain to reverse, and there's a ton of it. I stumbled on it by doing some user pivoting at one point and discovered, like, hey, there are all these little 4K like files getting uploaded, and they all have basically the same import table. They call kernel 32 DLL and exit process at this specific offset. And then something weird, the timestamp, right? So when you compile a program, there's a spot in the PE header where you can put the timestamp the purpose for the date timestamp field in the PE header is so that you can identify when the program was built. I would say that for a large portion malware, that's just that's garbage data, and this is no different, right? In this case, the timestamps are all bogus and like set way in the future. I'm not sure why Venom does that. I'm not sure that the attackers that use it know that it does that, but it makes for a real easy Yara rule. So I wrote this Yara rule and used this to kind of hunt around in the stuff that I'd extracted and pulled down. And what I found, like I said, was a couple hundred of these across lots of different counts and anonymous uploads, and started mapping these and found some pretty interesting stuff. I don't know, like it's hard to go down the next set of rabbit holes, and I'm a little cautious to want to do that publicly, just because yes, it's an available tool, right? Like everybody who's got a Kali box has Venom. What happens next with Venom is really based on what you do with the shellcode payload. So really the next piece of this would be to do a bunch of sandbox runs. But I saw a bunch of weird stuff like call outs to Comcast and Cox Cable and like home class stuff. You don't normally see that with people establishing C2 or running pen tests. So I don't know if it's like lower level bot activity or if it's like people screwing around with their staging this stuff on their own home networks. It's definitely an interesting piece of kit that I found out there. So now I want to pivot to kind of the next gen of the research that I've been doing, and that's really been around hunting PowerShell. So everybody get a chance to check out Dave Kennedy's talk this morning. So I love watching Dave Kennedy talk. He's He's right about most of the things he has to say about defensive operations and detection and how we can level our game up. But a lot of the stuff that he was showing off around PowerShell is stuff that's most definitely used in the wild, and Pastebin's no exception. So I started playing around with code that would just find interesting pieces of PowerShell and let me know when I was up against some PowerShell that might do some things that malicious PowerShell would do, right? So system convert, that's the library that does string conversion. So that's everything from ROT to base64 to hex encoding to Unicode encoding, right? But that tells you we're transforming the value of a data, right? This is not a thing that your sysadmin does unless they absolutely have to, right? Like if this is a legitimate administrative PowerShell script, you're not likely to see this. From base64 string, I'd say about half the time. Obfuscation isn't always bad, but it's usually interesting. New object system I/O, that's just saying, hey, I'm gonna write a file or open a file or declare, not only files, but certainly if you've got a PowerShell script that wants to write a file like, say, a PE binary that we decoded from base64, you're going to see some system I/O objects in there. System.net, if I want to use any of the functions like download string or HTTP request to go pull something else from somewhere else. And then system reflection assembly name. Man, this one's hot. Because the thing your sysadmin's really not doing? Your sysadmin is really not hot patching DLLs on your mail server. So system reflection assembly name is for reflectively loading bytecode into memory. Now there are really legitimate reasons to do this in .NET and things like that, but this is just this is one of those features of PowerShell that makes it really powerful, but really I see this used almost exclusively by bad guys. Every time I've found this, it's been shady. So I did some hunting, and as I promised Kiddies. So Kiddies it is. Let's start there. In addition to PowerShell, some of this stuff will also flag interesting Visual Basic code, so I found some heavily obfuscated. This is AES encrypted, base64 encoded malware packed away in all these interesting and strange comments. This would have been really, really annoying to reverse by hand, but fortunately, he did such a nice job commenting his code. I don't know, can you guys see the link to his YouTube channel? where he was kind enough to provide instructions on how his crypter worked for dropping malware, so it made my life a lot easier. This dude still totally active, as of last week, which is fantastic. So, okay, so I promised Kiddies. I also promised APTs. So I don't know if you would agree that Finn7 is or is not an APT. I mean, if they were, I guess Mandiant would have called them APT7. I think the name was taken. But everybody knows Finn7 now, right? They're not quite Fancy Bear famous, but they're getting there. One of the biggest, financial attackers, sometimes also called Carbonac, and a few other. They have some spider name that CrowdStrike gave them too. So here's a timeline anyway of Finn7 activity using Pastebin. So they ran 4 actual campaigns that we could observe over the last year where they leveraged Pastebin. One, they ran 2 TinyMet. So TinyMet is a PowerShell micro meterpreter implementation. They ran 2 TinyMet campaigns, one back in July of last year, and then one in August of this year. They also ran a DNS Messenger campaign in October of last year. If you're interested in the details on DNS Messenger, that one actually, there are a couple of really good write-ups. And I think the best one I've seen on is the one that the Talos team did. So if you Google Talos DNS Messenger, you get a good write-up on that Maldoc campaign. And basically how they were using Pastebin, by the way, is they were staging malicious PowerShell scripts for loading stuff, and then they were calling out to those from their Maldocs. I could be wrong, but I want to say DNS Messenger might have actually been a DDE auto attack. And then of course, we wouldn't be able to call them Carbonac if they didn't actually use Carbonac still every once in a while. So back in just this last previous month in September, they ran a Carbonac campaign where they staged the payload again. So, and here's how the stagers look. So from base 64 string, just like I showed you, that's how we caught it. That H4SI is anybody, I got giveaways, so you can have your choice if anybody knows what H4SI is in base 64. I'm gonna have to come up with easier questions, that's fine, I got you. Nope, no, TVQQ is MZ, that's too easy. H4SI is a gzip header. So anytime you see a base 64 string that includes starts with H4SI, you're going to have to decompress the contents of it. And so I did. And then you find some other stuff. In both the TinyMet and the Carbonac campaigns, they used a loader that used this from base 64 char array. That's not a reserved word. That's just a variable name they picked. So that was interesting for helping tie that back together. And then in those they also just hex encoded the PE file. So hunting so the same stuff that we're using to find commodity level malware sitting out on Pastebin, same tactics, basically get us the pros too. So, okay, I did promise APTs, right? And we can argue about whether, how copy kittens are in the realm of APTs, but they are government backed. So, Operation Wilted Tulip was an attack committed by an actor called Copy Kittens. I'm not super big on attribution, deconfliction, so yada yada yada. It's a RAN. So here's a timeline of activity, and I want to be clear, the existence of this stuff on Pastebin, this was an interesting lesson for me. As far as I can find, I reached out to basically anybody who talked publicly about Wilted Tulip, and the folks at Clear Sky were really did a big write-up on it. They were super helpful about with trying to deconflict some of the stuff that I found and observed. And to be clear, nobody ties Pastebin to the actor. So what I'm tracking here is Copy Kitten's kit from the Wilted Tulip operation probably being passed around by responders or researchers. So blue team, don't upload to VirusTotal, blue team, don't post to Pastebin, right? Because I see you. But this is a whole series of kind of activity, and it suggests that as we move into early 2018, and that really is the last of it in February 2018 that I observed. But that means either people were still continuing to find and respond to pieces of that operation and pass that information around, or there were, I struggle to explain exactly why it was there, and not because I don't have theories, but because I want to be real cautious about what I put out there in terms of guesswork versus what actually happened. But what I can confirm is that these files are definitely known and identified as being part of that operation. So here's kind of what the kit looked like. So highly obfuscated backticks, which are like PowerShell no-ops. Makes it a real pain in the butt to read, but it's pretty easy to kind of cut out. I don't see him in the room, but hopefully maybe later Dave Kennedy will actually watch this talk, because he talked about how much fun he had breaking up and reordering strings to hide payloads in his talk this morning. But that doesn't really work if what we're looking for is small byte sequences pre-encoded, right? So yes, this is not super easy to put back together, but it wasn't super hard either. But we still detected it, right? That's still a PE preamble right there, TVQQ, like you can't miss it. So those are the MZ bytes at the beginning of the payload. And of course, so Operation Wilted Tulip, the final payload for that, what they were using to establish foothold was Cobalt Beacon, because that's what all good attackers use these days, I'm told. So I'd actually want to thank Ryan, and he just happens to be standing right here, thank Ryan for his help Ryan did a ton of research on Cobalt Beacon config extraction. So actually, as of this morning, you can go out and download the BAMF Detect modules off of my GitHub repo that include Cobalt Beacon config extractor for HTTP. Works all versions. So thanks to Ryan for that. Okay, let's try the giveaway thing again. Can anybody tell me how you can tell the difference between a licensed and unlicensed version of Cobalt Beacon? It's super funny. No guesses? What's that? Oh, no, you can't see it on this screen. It's on the next slide. In the back? Yep. Yeah, yeah, here, let him take his pick. So yes, what the guy in the gentleman in the back was describing is that yes, what Cobalt Strike does to Beacon when it's built without a license is they stick the EICAR string in it, which ironically doesn't get detected as much as you would hope, since that's literally the purpose of that string. Is like every standard antivirus engine in the world is supposed to alert when it sees that string, and most of them don't. Which is, at least not when it's put at the end of a PE file like this. But this is a fun piece of kit. So Iran not paying for Cobalt Strike. But there's more Cobalt Beacon, and like I said, Cobalt Beacon is the stuff of APTs. So as part of this research, and then with Ryan's help, we went back and back hunted all this stuff that I'd captured with the scraper, and found a bunch more Cobalt Beacon. And now, if you upload Cobalt Beacon in just an encoding format that the bot recognizes, I will dox you and send your stuff up to VirusTotal. So if you're a pen tester, don't stage on Pastebin anymore, because I will tweet you out. Like I did to these folks. So more pew pew maps. This one's kind of interesting though. So I don't know if I have an APT here or not. Let's play a game, shall we? So I don't know if you can read this. So there's an IP address up there, 54.174. Anybody know where that's at? Who said Amazon? Give that nice gentleman a giveaway. Yes, so that's Amazon. But tsk-greenenergy.com, it turns out, was registered with Namecheap, and it is not the property of TSK GmbH, which is an energy company based in Europe. But boy, it sure sounds like them, doesn't it? So APT or not APT? Not. Yeah, so I agree, right? So Namecheap, hosted on Amazon. Something you don't know is that this is a licensed version of Cobalt Beacon. Something else you don't know is that when they set up the domain, they configured it to use Amazon's name server, so they knew when they registered the domain they were going to hang out in Amazon. So everything about this says I was paid for with a legitimate credit card. So I don't think that's an APT. I think we caught a red team test that looks or was trying to look like an APT. So that's fun. But those yellow dots up there, you want to guess what the yellow is? Unlicensed Cobalt Beacon. And it's all hanging out in Japan on different ISPs. So that's fun. So I can't say conclusively that that's an APT, but it's definitely a lot shadier than that one turned out to be. All right, what else? Empire Agent. So everybody familiar with PowerShell Empire? I see a ton of Empire Agent now that I know to look for it. So PowerShell Empire Agent looks like every other base64 encoded PowerShell script. When you first see it, you decode the first round and you come up with this, and it will make a call out to a dropper. That's totes legit. You see that coming off of your network. What this is though is this is just a stage dropper. This isn't the actual bot. Empire Agent is a PowerShell bot, and so if this had actually been able to run to completion and pull down admin.get.php, admin.get.php is an encrypted payload with the actual PowerShell in-memory resident bot in it, which this then decrypts with the IV and all the rest of that. It's really not too bad. Like you kind of. Follow me on Twitter if you're curious about how to pull the rest of this apart. I've tweeted out about a couple of these I've found before, but basically you pull the file down using wget. You got to recreate the cookie and the user agent, get that down, fire up PowerShell, and put the key bytes in, run it through, decode it, and then you get the rest of it. The best part about what comes out the other side of these, though, and I should have made a slide for it, I'm sorry, is that it camel cases the next version of this, which includes the static user agent string that it uses to fake this. So the user agent string, if you look up there, you can find the, look for Mozilla up here up above. And that looks normal cased, but the final version that has the continuous ongoing beacon will incorrectly camel case the Mozilla user agent string for PowerShell agent. So if you're hunting for PowerShell agent on a network, go look for miscased Mozilla, and you'll almost always come up with that. So this is fun. This is some of the places they hid it around the world. C2 in the Seychelles, C2 in Bulgaria and Romania, and so totes legit. Okay. And finally, PowerShell Meterpreter. I just put these together like this morning. So PowerShell Meterpreter is the thing I've been playing with as well. This is another piece of kit that Dave showed off some of the functions that this performs in his talk this morning. So the PowerShell Meterpreter dropper, again, looks just like every other obfuscated PowerShell script. You can't really tell going in that that's Meterpreter, but using some of the same using some of the same byte recognition stuff, we're able to identify that, hey, this is something we should take apart. We get in. There's H4SI again, so it's gzip compressed. You're gonna have to pull that apart. So it's a few rounds. It's kind of a pain, but I've managed to automate this and just added this functionality to the bot like a week ago. So I went through and pushed like another 40 or 50 of these back out, uploaded them all to VirusTotal, been playing with it. I think a couple went out this morning, as a matter of fact. This is stage 3, so you actually start to get a look at what the PowerShell actually does. So anybody recognize what that code is trying to do and what that last base64 encoded string is going to be? Anybody got a guess? So that's basic. Sorry? Yeah, so what do you think we're doing in memory? What? In that case, it's not actually a NOP sled. Although, pro tip, if you're looking for NOP sleds in base64, they look just like they do everywhere else. It's like all A's. So if you see a big string of A's in base64, that's nulls. So I've been staring at a lot of base64. I'm starting to speak it. So in this case, though, it's shellcode. And this is the actual base64 encoded Meterpreter shellcode. This one is reverse TCP shell. And what it's doing is it's invoking it, as you said, into memory. In this case, I think it's kernel 32 DLL. I think that's up above in the script. So what you get out if you decode that base64 is this block of hex. And you'll just have to take my word for it that this one would have called out to 192.168.229 on port 80. But because it's because that reliable shellcode imprint that we can get from playing with the interpreter, it's not hard to go through a series of these, find the particular byte offsets and encoding patterns, and automate decoding these. So that's what I've been doing for the last week or so, playing with this, trying to hunt and automate doxing more of the bad PowerShell. So the other day, I found this guy. He looks like so many others that I see, and nothing unusual there. Decode it, the stage 1. So this is what it looks like when you do that first round of decoding, and Again, nothing super weird. If you look in the upper right, it's gzip encoded. We're kind of expecting that. It makes sense. We get to stage 3, and hey, look, same thing. We're trying to inject into memory, but oh, that's cool. It's going to call out and download something over HTTP. That's pretty sweet. Staged on Imager. That's awesome. So I went like an excited kid on Christmas morning, because my Christmas is probably much worse than yours. As I say it out loud, it sounds like. I went out and I pulled the file down, but I was totally expecting to find like an FCE8 or a DBBD, like 32-bit or 64-bit point of reference for some shellcode, and I didn't find it. What I found was, as described in the URL, a PNG file. So somebody was saying hello. So I think at some point I must have gotten a hold of something in the middle of something, and I don't know if this was meant for me or someone else, but I'd like to think that this is some red team trolling back against someone, and if you did this and you saw it, please hit me up on Twitter. I'd love to hear the backstory. And if you're a bad guy, laughing at home, well, good, well played, good burn. All right, that was my talk. Thank you for listening. All right. Okay, I've got one last giveaway, so whoever has the first question can get a book. Red shirt in the back. And your question? Yeah, so mostly, right, so what I get is I get code and tools, so I'm looking at code and tools and then hoping to kind of look at, so the idea is to go from code sets and tools to infrastructure, and hopefully based on the connection of those two things, maybe identify an actor based on that. I didn't start out trying to track APTs. It just, they just kind of showed up in the mix, and I thought it was interesting. So, cool. Any other questions? Yeah. So the question from the audience was, do I track how many of the pastes are set to auto delete? Yes, I do. For anonymous pages, as you may be aware, right, they can set an expiration, and I do record that. So ones that are being used for testing seem to last about 10 minutes to an hour, and ones that seem to be part of an actual attack that they don't want to be out there for long periods of time will typically be a day to a week. Is about what I see. I haven't actually done a full set of analysis on that. That's just casual observation. But if you message me on Twitter, I'd be happy to just share the data with you around that. Cool. Anybody else in the back? You're gonna have to shout or use the use the mic.
Can you hear me?
Yeah.
So what's like the end result that happens to them bad guys there?
So, I'm sorry. Can you a little louder into the mic?
So like, what's the end result that happens to the bad guys that you catch? It varies widely, right? Like. The primary automate, there's so much out there that I don't have time to file abuse reports. There is a family of malware I'm playing with right now that actually does uniquely register each piece of malware and have a way to report abuse. I'm thinking about adding that, but by and large, what happens is they get their stuff uploaded to VirusTotal and posted to Twitter, and unless there's something especially concerning or egregious, in which case then I might reach out, but that's only if I happen to catch it. All right. All right. So the question was, do I do anything to obfuscate my IP when I'm downloading stuff? Yeah, I use a combination of things. Yeah, I tell you about it in the hall, but there's, it's not hard. It's pretty rare to see something that's actually IP or geo-locked and that's holding a next stage, but yeah, I have ways around that. But you proxy, change the IP in the cloud hosting service, or Tor. Usually one of those three. I haven't had anything where I couldn't get to it. All right. Well, if that's it, then that's it. Thanks.